Alright, so in this video what we're going to be talking about is the zeros of polynomials and how that impacts what their graph looks like. So we're going to be looking at a few different things. We're going to go through an article real quick. And something you need to understand when we are looking at polynomials. You will hear terms of zeros, roots, or factors, or x-intercepts. So what I have is I have Desmos up here. I'm going to show you guys, if we just type in a random linear function like x minus 2. Alright, so this is called a linear factor, and it creates a line, okay? And you can see that we have a 0 right here at 2, 0. Alright, so x minus, like what number minus 2 is 0? Well, 2, so that lets you know the 0 of that function. Right? Let's say if we make it a quadratic and put like x minus 5. So we have a linear factor, x minus 2, and another linear factor, x minus 5. But when you multiply them together, you get a quadratic. So now we have two zeros, one at 2 and one at 5. Okay? So why are these called linear factors? Well, if you make the lines, you'll see that these actually pass through the zeros right here. That passes through the 0, 2, 0. That passes through 5, 0. So these linear factors pass through the zeros of this quadratic. What if we just add one more? X plus 3. So now I'll zoom out a little bit. All right, we have a cubic function. All right, now it has 3 zeros. So what number plus 3 is 0? That would be negative 3. And then we know our other two zeros, 2, 0, and 5, 0. So whenever it's talking about factors, or zeros, factors, x-intercepts, that's what it's talking about. It's talking about these numbers where the graph goes through or hits the x-axis. So the next thing we're going to be talking about is what's called this concept of multiplicity of zeros. So a multiplicity means it happens more than once. Okay, so for example, let's say if I type in x plus 3 again. I'll head home so you take a look at it. Look at the difference right here. These, there's 1. There's 1 0, but here it touches because look, we actually have, this is called a multiplicity of 2. But we're not going to write it as x plus 3 times x plus 3. We'll write it as x plus 3, and then we'll just square it. All right, so look what happens whenever I decide to square something. All right, so this is a multiplicity of 2. This is a multiplicity of 2, which basically means I'll just rewrite it real quick, all right, so you know what I'm talking about. X minus 2, x minus 2, we have x minus 5, x minus 5, and finally we have x plus 3, and finally another x plus 3. Okay, so this is this is kind of like when you combine it, making something squared. This is everything just kind of expanded before you multiply everything out. So you can see that these are the same. These are the same graph. Okay. So what happens every single time? Now I could put a negative sign here if I wanted to, right here in the front. And you'll still see the zeros have not changed, but it's not passing through the x-axis. It's touching it and then changing direction. So watch this. Watch what happens here. If I take that 2 away, now what's the only 0 that it passes through the x-axis? At 2. The other, they don't pass through. They just touch it and move on. What happens if I take away that? Now the only one that has the multiplicity of 0 that touches the x-axis. These go through it. So whenever this number is even, okay, watch. If it's even, it still just touches it. See what I'm saying? Still touches it. But if it's odd, that's when it's going to go through it. So if I wanted to make these touch, boom. Now you can clearly see that these touch it. This goes through it. So that's kind of that's the concept right here. All right. So here we go. Scroll down. All right. So right here, if we wanted to find our zeros of this quadratic, you just figure out what number would you plug in there to make it equal to 0, and what number would you plug in there to make it equal to 0. So a -4 and a 7. So those are the numbers that make the zeros of the function. Okay. The graph of function g crosses the x-axis at 2, 0. What must the root of the equation of g of x equals 0? Now what is that saying? That's basically saying, you know what, I'm going to go ahead and get my notes real quick. Alright, I got my tool here. Let's go ahead and talk about this. So if it crosses the x-axis at 2, 0, that means it has a factor at x minus 2. And like, what number would you have to plug in there to make it equal to 0? You'd have to plug in a 2. So it says, what must a root of the equation be? Well, the root must be a 2. And that's what you're going to be typing in right here. All right. So over here, it says the zeros of function h. All right. The zeros of function h are -1 and 3. Which of the following could be h of x? All right, so let's take a look at all these answers, and we're going to tell you what the zeros are for each of these, okay? So right now, I'm just going to write zeros. The zeros are at x equals 1 and x equals -3, because 1 minus 1 is 0, and -3 plus 3 is 0. Over here, the zeros are going to be at x equals -1 and x equals 3, because -1 plus 1 is 0, and 3 minus 3 is 0. And that's going to be our answer that we're going to choose. Right here, our zeros are going to be at x equals 1 and x equals 3, because 1 minus 1 is 0, and 3 minus 3 is 0. And then you can probably guess what this is going to be. My zeros will be at x equals -1 and x equals -3, because -1 plus 1 is 0, and -3 plus 3 is 0. All right, so when it asks you for the zeros of the function, they tell you the zeros, you can build your function from the zeros. So -1 and +3. Okay. Now it talks about multiplicity, what we were talking about earlier. Okay. So for example, if we have x minus 4 squared, they call that a multiplicity of 2, because we get it. We can plug in number 4 twice and it still makes a 0 in the function. Okay, so here, which one has a multiplicity of 3? Well, that would be 1, because 1 minus 1 is 0, and you can do that 3 different times. So we're going to say 1. So it has a multiplicity of 3. All right, which one has a double 0 or has a multiplicity of 2? So this is one where I want you to understand the difference between these two, okay? And we're going to go and actually type this one into Desmos too, so you can see the difference. So you'll notice that this is an odd degree, and this is an even degree. So a double 0, if I were to rewrite this, this has a multiplicity of 3, which x plus 1 times x plus 1 times x plus 1. But this has 2x plus 1 times 2x plus 1. So this is called a double 0. So we got to figure out like what number would we plug in here to make it equal to 0. So I have there's a little shortcut. There's two ways you could do this. You could put 2x plus 1 and set it equal to 0, and then solve for x by taking away 1 from both sides and dividing both sides by 2. And you get x equals -1/2, which is going to be our answer. But another way of looking at any fraction, all right, so I'm just going to make something up here. I'm just going to call this a. So this is a linear factor. Ready? A times x plus b. So let's just make up a number for a. Let's call it 7. Let's make up another number for b. We'll call it 3. All right. So if I wanted to find the answer to this, all right, the answer that you would plug in will always be -b over a. It's always the negative version of this number over this number. So this right here, here's our a value, here's our b value. So I'm just going to say x equals -3 over 7. And that would be my answer that I could plug in there to make this equal to 0. Now I could set it up and equal to 0 and solve for it. You can still get the same answer, but the shortcut is just saying the negative version of this over this. So I'll say it another way. Let's say I call this 4 and a 5, minus 5. So what's the negative version of this? 5 over this, 4. So I know my root would be 5 over 4. It's the negative version of this number over this number, and I'm done. So that's just kind of a fast way of doing it. Hopefully that made sense. If it didn't, I apologize. All right, so let's make a, oh, I said I was going to put this into Desmo, so I apologize. I'll go and do that. All right, so we have, delete this. So I believe it was x plus 1, all right, and that was raised to the power of 3. And then we had 2x minus, or 2x plus 1. I think so, let me check. No, 2x plus 1, yeah, and that was squared. That was squared. Okay, I'm kind of have to zoom in here so you can kind of, all right, one of them actually, wow, we have to really zoom in here. One of them actually passes through, so this actually passes through, and the other one right here at a half does not pass through. We'd have to really zoom in so you can see that this actually crosses over the x-axis, but this one does not cross over. And the more we zoom in, the more you could see that it does not actually cross over, just touches it. Okay, it's kind of hard to see, especially if you're zoomed out. It looks like it's kind of hard to see that it, you can see from there, it doesn't touch. It just touches it and goes back up. All right, so if we were to look at this graph right here, we're just going to build a function off of its zeros. So it says, what could be the equation of p? All right, so what could be the equation? So it crosses through right there. So that factor would be at x plus 2, because negative 2 plus 2 is 0. Then it touches it, but doesn't pass through. It just touches it, and that's at 0. So I'm going to call that could be at x squared. And then finally, right here at the end, it goes right here at 2.5. So at 2.5, we could say, let's see, we could call that 2x minus 5. All right, because 5 over 2 would be the number that I would plug in to make that equal to 0. 5 over 2 is equal to 2.5. So how do I get that 2x minus 5? For example, let's say it was at 2. Then the answer would be x minus 2. If that was at 3, then the factor would be x minus 3. But if it's at x minus 2.5, I got to make this into a fraction. I got to make it into 5 over 2, which is 2.5. So I got to rearrange it. Okay, remember it's the negative version of this over this, so I got to make it 2x minus 5. And that probably doesn't make sense to some of you, but basically I want you to understand that this could be the function, okay? Because this graph opens up, which means it's an even degree function. All right, so that's x squared, that's x to the power of 1, that's x to the power of 1. All right, and it has a multiplicity right there at 0, so it crosses it only at negative 2 and positive 2.5. So that's what I'm going to be looking for. All right, looking for x squared. All right, and then we have 2x minus 5 right there, and we have x plus 2. And that could totally be our answer. And this is what you're going to be looking for when you're looking for multiplicity of zeros. Okay? So I'm going to go ahead and let's take a look at one of our examples right here. All right, see if we get one. Here, check for our understanding. Okay? It says in the graph function, okay, is the multiplicity of 0 6, even or odd? So right there, see how it passes through? That would be considered odd because it's only going to go, if it goes through it, it's an odd degree. But if this would be even because it touches it. So at x plus 4 it would be even. Here it's going to be odd. So let's go ahead and do a few problems here, okay? Let's see how, here we go. Let's do a few problems. Okay, so we got to figure out what's happening here. So that touches it once. Okay, so that's an odd. Here, it touches it right here on the x-axis. So that's got to be an even. So I'm just going to kind of map it out. This goes up like that. So I'm going to say it could be, oh, that's a point of inflection right there. So I could say this would be at x, instead of x minus a half, this has to be an odd number here. So I'm going to put 2x minus 1, and that could be a 1, it could be a 3, it could be a 5. But over here, at x minus 2, it's got to be an even. So this number has to be an odd, like a 1, or a 3, or a 5, and this has to be even. So that's what I'm going to be looking for, because this one doesn't pass through, and this one does pass through. So let's take a look at this. Take a look at our choices. All right, so see right there how that's odd? We know this one has to be odd and this one has to be even. So this could definitely be an answer choice. And it's positive because it goes up from left to right. So that's kind of right now, that's my best answer. Yep, that's definitely it. So notice, this one is odd, so it passes through it. This one is even, so it just touches it. So that's going to be our answer. All right, let's take a look at this one. This one touches it, so looks like there could be a double root right there. There could be another double root, and that's a single root. All right, so if we were to write this out, where do we have a double root? Right here at -3, so I could put, looks like we're probably going to have x plus 3 squared. Then we have a single root here, so I'll just put x plus 1, and then we got a double root, looks like right here. So I'm going to put x minus 2, and I'm going to square it. So these two right here, this one here and this one here, definitely need to be even. This one definitely has to be an odd. So that's what I'm going to be looking for. Just even, even, odd is what I'm looking for. All right, let's check this out. Got even. Okay. Even right here. Even right here. Oh, that's even, even, even. That's not it. Got to keep going. Keep going. Here we go. X plus 2 at -3, even. Got even here. Odd. This is the one I am liking because at -3, it's even. At +2, it's even. And right here, x plus 1 at -1 right there, that's going to be odd. So I'm choosing D. Okay? And that's what you're doing when you're trying to figure out which one it is. Without even having to use a graphing calculator, you can figure it out just by knowing whether it passes through or whether it just touches the x-axis. And when it touches the x-axis, that's called a multiplicity of zeros. Hope you have a good day, and that's all I got for you.